This is Preview.
Hottest temperatures of any planet, even Mercury, plus an atmosphere composed almost entirely of carbon dioxide, which creates a hellish greenhouse effect, and dense layers of clouds composed of sulfuric acid.
The Axiom is a virtual city in space designed to accommodate the needs and desires of each of her 600,000 passengers.
There are some basic things you should know about Mars before leaving home. Most days will be clear and sunny and cold. The average temperature on Mars is as bitter as midwinter in Antarctica. At about half the diameter of the Earth, Mars is a handy size, but it's much less dense than Earth, with about a third of the gravity. Surprisingly, the actual surface area is so thin and cold that water exists only as solid ice in the ground or vapor in the air, not as a liquid on the surface.
It looks like a castle made of ice and could become man's home on the red place. An inflatable membrane is used to create an interstitial environment between the outside of the capsule and the Mars atmosphere. Rovers would then extract water from the ice below the surface at Albemarle and apply it to form a protective skin on the inside of the inflatable environment. Not only does the layer of ice provide protection from radiation in the outside atmosphere, it is also translucent and allows light into the habitat. By conditioning the environment within the inflatable section, it is proposed that the ice be kept frozen indefinitely and vegetation could be grown, which would help to convert carbon dioxide into oxygen. With water as the core resource for future outposts on extraterrestrial, the settlement on Mars will be constructed by an array of pre-programmed, semi-autonomous robots prior to the eventual arrival of the astronauts. The habitat will be delivered in 2 stages prior to the arrival of the astronauts. First, the semi-autonomous robots select the site and dig a 1.5-meter deep crater, followed by a second delivery of the inflatable modules which sit within the crater to form the core of the settlement. Given the vast distance from the Earth and the ensuing communication delays, the deployment and construction is designed to take place with minimal human input. The loose Martian soil is then fused using microwaves around the modules using the same principles involved in 3D printing by several small melters. The fused regolith creates a permanent shield that protects the settlement from excessive radiation and extreme outside temperatures. The separation of tasks amongst the large number of robots, and the modularity of the habitat means a high level of redundancy is incorporated within the system. If one robot fails, or a single module is damaged, there are others that can fulfill its task, increasing the chances of a successful mission. The
massive global warming effect, something that humans seem pretty good at. And scientists have come up with three main ways to do it. The first and easiest way might be to just build factories that would basically turn carbon, fluorine, and sulfur in the Martian soil into greenhouse gases and pump them into the atmosphere. This would unlock one of Mars's greatest assets when it comes to warming things up, the thick layer of dry ice or frozen carbon dioxide that covers its south pole. An initial burst of greenhouse gases could cause this ice to sublime directly into vapor, releasing carbon dioxide gas that would help trap more heat from the sun, in turn releasing more greenhouse gases. But all that would mean 200-kilometer-wide mirrors in space. They'd reflect sunlight onto the Martian ice caps, raising the surface temperature and releasing that carbon dioxide. If neither of those ideas worked, there's always the possibility of bombarding the planet with asteroids. In this scenario, we'd capture asteroids on the edge of the solar system and use rocket engines to propel them into Mars. The ammonia in the asteroids would act as a greenhouse gas.